Hi guys. So today we'll be doing a little bit of revision from the topic on general organic chemistry. I guess most of you might be aware that a lot of questions are generally asked from this particular topic. So let's begin with the last minute revision. What exactly is resonance? Resonance is basically delocalization of pi electrons, and it normally occurs in the conjugated systems, right? So conjugated systems means it's basically a system wherein p orbitals are connected, right? So what are the different types of conjugated system? There could be, this is one type of conjugated system. This is a pi-pi system, if you remember, right? And then you could have something like this. You have a pi system, okay, and then you have a positive charge. Similarly, you could have one more conjugated system wherein you have a double bond connected to a carbon bearing negative charge and even a radical. Okay, so there are a lot of conjugated systems that you'll be studying, and you could even have something like this, a double bond, and this is in conjugation with a hetero atom which contains a lone pair. Okay, so this could be one of the conjugation. So normally resonance occurs in the conjugated systems, and it's basically flow of electrons. So if I have to show the resonance, basically how am I going to do this? So first I'm going to shift the lone pair over here and the electron pair gets transferred here. So this is basically what happens in the case of resonance. That's the reason I've written delocalization of pi electron. What does resonance actually do? That's a very important question. It decreases energy and increases the stability because the charge is getting delocalized. That means the charge is moving continuously from one atom to another. As a result of which, it's going to get drained out in energy. So a decrease in energy, and then it would come to rest much faster. So that means that's the reason, that's what you have written, increases stability. Now let's talk about the stability sequence. Now I've seen many students struggling in the case of stability of resonance structure because they have either too much knowledge. I'm not saying too much knowledge, but I would say that they apply too many concepts simultaneously. Here are the set of rules which you're supposed to remember. The first is it should be a neutral molecule, right? So if I have a molecule which is charged and if I have an uncharged, obviously the uncharged molecule, that is neutral molecule, is going to take the preference. Next is going to be complete octet. Then you have more number of pi bonds, okay, and negative charge on electronegative atom should be there, and if it's an electropositive atom then there should be a positive charge. Okay, let me give an example. So let's say if I have an sp2 carbon, okay, sp2 carbon, and let's say I'm going to write these structures, sp2 carbon, and let's say if I have another sp2 carbon. So let's say in one structure if I have a negative charge on this sp2 carbon, and in another structure if I have a positive charge on sp2 carbon. So you might be knowing that percentage S character is directly proportional to electronegativity, right? So this has more percentage as character, so this is more electronegative. So that means out of the two structure, this is going to be more stable. Next, same charge as far as possible. So let's say if I have a carbon chain like this, okay, I'm going to draw two molecules now. So I have two carbon chains like this, the same molecule. Now let's say if I have a negative charge here and negative charge here, right? And let's say if I have a negative charge here and a positive charge here. So due to electrostatic repulsion, this should be less stable, and the other structure, this is going to be more stable. Okay, so this is going to be more stable. So this is the next rule, that is called as a charge rule. Same charge should be as far as possible and opposite charge should be as close as possible. So if you consider these particular parameters, then you'll be able to solve the questions related to resonance stability in much easier manner. Okay, so this was about resonance. Thank you.